Good morning, students. Today we're going to be discussing the Pythagorean Theorem, the converse of the Pythagorean Theorem, and how to classify triangles using the Pythagorean Theorem. So here are your objectives. Make sure you copy them down, and let's get ready to begin. Okay, the Pythagorean Theorem says that if you have a right triangle, then the sum of the square of the legs are equal to the square of the hypotenuse. Okay, if you have a right triangle, then the sum of the squares of the legs are equal to the square of the hypotenuse. Here we are. Here is a right triangle. In other words, a squared plus b squared equals c squared. As I'm sure this is not the first time you see that. Okay, so if we have a right triangle, first thing you need to know is to learn how to recognize the parts of the triangle. You need to recognize the parts. So which are the legs, which one is the hypotenuse? The most important, of course, is the hypotenuse. The hypotenuse is always across from the 90-degree angle. Here is your hypotenuse, okay? The other two are the legs. So this is a leg right here, and this is also a leg. So it has two legs, and then the hypotenuse right across from the 90-degree angle. This is always the longest side, okay? The longest side. So make sure you understand or can identify the parts on the right triangle. Here are some Pythagorean triples, okay? Which only means that these numbers satisfy the Pythagorean theorem. That all these satisfy. I'm not going to ask you to memorize them, but it's good to do it, because that way it saves you time. Now, one curious things about the Pythagorean triples are that if you have 3, 4, and 5, for example, that means that satisfies the a squared plus b squared. So 3 squared plus 4 squared is equal to 5 squared. Notice that that's 9 plus 16 equals 25. And that is true. That is true. You see how this satisfies the Pythagorean theorem? Well, also understand that if I multiply any number by all three digits over here, let's say I take 2, and I say 2 times 3 is 6, 2 times 4 is 8, and 5 times 2 is 10, right? Equals 10. Okay, notice that 6 squared is 36, plus 8 squared is 64, 10 squared is 100, and this is true because 36 plus 64 is 100, so 100 is equal to 100, so it is also true. So as long as you multiply this by the same factor, all three numbers, all three, then you are going to also get another Pythagorean triple. So that is good to know. So that means that if you have on these 3x, 4x, and 5x, where x is a factor, then as long as you do that, this is also a Pythagorean triple, okay? So understand that part. You could go ahead and try some and see it for yourself, okay? So always prove things to yourself so you know what we are talking about. Like if you take 5, 12, and 13, there's 5x, 12x, and 13x, make x any number, and check if you square 5 squared, 12 squared equals 13 squared, then notice that when you do 5x squared plus 12x squared equals 13x squared, okay? So make sure you check that out for yourself. Here's things. Okay, here are some examples. Round to the nearest tenth. Okay, so the first thing you want to do is draw this on your paper. This is your right angle right over here. This is your right angle. Identify your parts. These are your legs, and this is your hypotenuse. I'm going to show you a shortcut. If you have a squared plus b squared equals c squared, notice that I'm going to show you why it works. So that means, let's say I'm looking for a. not 4, which in this case, let's call this a right here. Instead of x, let's call it a. Let's say I'm looking for a. Notice that a squared is equal to c squared minus b squared, because I subtract b squared on both sides, right? And to get rid of that, then I just say, well, the square root of a squared is equal to the square root of c squared minus b squared. So if I am looking for a leg, like a, for example, then that would be equal to the square root of c squared minus b squared. And that is true, because learn this, because this is a shortcut of the Pythagorean theorem. So this is if I'm looking for a leg. Let's say I'm looking for the hypotenuse. The hypotenuse will be c, right? Always c. That's the part that you need to understand. A, B, C, or A, B, C. The legs doesn't matter how you call them, A or B, but the hypotenuse must always be c. So let's say I'm looking for the hypotenuse. If I am looking for the hypotenuse, which is this right here, well, I know that c squared equals a squared plus b squared, right over here. Notice that if I want to find c, all I have to do is, well, c, do this right here. C is equal to the square root of a squared plus b squared. That will save you a lot of time. So now, if I'm looking for the hypotenuse, ooh, that kind of looks messy. Give me a second. If you're looking for the hypotenuse, or c, then you want to use this formula right here. That's a shortcut, okay? That's a shortcut. And that's how I got it. So know how I got it. I just solved for the original formula for A and then for C. A being a leg, doesn't matter. A could be this leg or this leg, doesn't matter. And C being the hypotenuse. So now I have two little formulas that you should copy down, because now I'm going to show you how to use them, okay? Here we go. So let's say I'm looking for a leg right here, because I know the hypotenuse is right here, that is given. So since I'm looking for a leg, I know that the formula says that A is equal c squared minus b squared. Well, there is c and there is b. Notice that x is going to be equal to the square root of 14 squared minus 9.4 square. Now all I have to do is go to the calculator. It says round to the nearest 10. So notice that I put control x squared, because this, see how mine is in blue, yours may be in some other color, probably yellow, but mine is in blue, so I press that blue key and then go for that square root. See it right there? So now I put 14 squared minus 9.4 square. You press enter, and here it is. So that means that x is about 10.4, because it says round to the nearest 10, so it's 10.4. So x is approximately 10.4 centimeters, and that would be my answer. Now, when we are talking leaving the simplest radical form, notice the first thing I want to ask myself, what am I looking for? Again, here's my hypotenuse. If this is my right angle, here's my hypotenuse. So the rest are legs. So I'm looking for a leg. So A is equal the square root of c squared minus b squared. So that means x is equal the square root. Remember, the first one is the hypotenuse, so it has to be this number, 12 squared minus 8 squared. So let's do it by hand. 12 squared is 144 minus 8 squared is 64. That would be x. So that means x is the square root of 80. Now, to find this in the simplest radical form, remember at the beginning of the year we went over this, how to simplify radicals. I want to break this number into its prime factors. So you could do it on the calculator. I'm going to show you both. If you're going to do it like this, you could say, well, 80, that's 2 times 40. 40 is 2 times 20. Notice 2 is already a prime number, 20 is not. This one is 2 times 10, right? Lower this. And this one is 2 times 5. In other words, that would be 1, 2, 3, 4. You got 1, 2, 3, 4, and then a 5, right? So that's 2 to the 4th power times 5. Okay, so now that I have that, I want to see how many pairs. Notice I have a pair of 2's right over here. So I pull that out. I got another pair of 2's right over here. So I pull that out and place a multiplication sign. Remember, we're multiplying. So I pull those 2. Now the 5 does not have a pair, so I'm going to leave that like in prison, right? Remember that? So now all I do is resolve it. So x is equal to 2 times 2 is 4, square root of 5. And that would be my answer. Notice to do this in the calculator, all you have to do is press menu, number 2, right? Oops, let's do it again. Menu, number 2, which is number, and then number 3, which is factor. And then I just put 80, enter. Notice it gave me what I found. 2 to the 4th power times 5, which is what I have here. 2 to the 4th power, 1, 2, 3, 4, or 2 times 2 times 2 times 2 times 5. All right? So practice on those because we're going to be doing a lot of those in this unit, okay? So practice resolving or simplifying radicals. Okay, so here's the converse of the Pythagorean theorem where it says, in a triangle, if a squared plus b squared equals c squared, then the triangle is a right triangle. Remember, if it is a right triangle, then the sum of the square of the legs equals the square of the hypotenuse, which is a squared plus b squared equals c squared. Well, now the converse of it is when you change or switch the hypothesis and conclusion. So if a squared plus b squared equals c squared, then the triangle is a right triangle. Here is an example. Is the following, or are the following right triangles? And we're talking this one and this one, right? So the first thing is we don't know where is the right angle, but I do, because if this is a right triangle, then this, the largest side, would be the hypotenuse. Therefore, the right angle would be here. But I do not know if it's a right triangle, so that's why it's not marked. So the first thing I want to do, I want to see if it satisfies a squared plus b squared equals c squared. So I know who c is, so this is a and b. So 10 squared plus 24 squared equals 26 squared. Well, I know this is 100 plus 24 squared. That's 576. And then 26 squared. That's 676. Now notice that 100 plus 576 is 676, and that equals 676. So yes, it is a right triangle. So yes, it's a right triangle. Now there's another way you could do this in the calculator. Let me show you real quick. So if it's true, it's going to say true. So 10 squared plus 24 square is going to be equal 26 square. And at that point, I see it says true. So that means that is a right triangle. So if that is the question, I could solve it that way, and it will tell me whether it's true or false in the calculator. Now let's take a look at this one. A triangle with length 6, 8, and 11. Which one is the hypotenuse? If you said 11, yes, that is true. 11 would be the hypotenuse because it's the largest side. Well, I want to check that. I want to check if this is a right triangle. So 6 squared plus 8 squared equals 11 squared. Well, 6 squared is 36. 8 squared is 64. and 11 squared is 121. Well, 36 plus 64, that's 100, and 100 is not equal to 121. So therefore, this is not a right triangle. Okay, so, but what is it then if it's not a right triangle? Well, we could go to an offshoot of the Pythagorean theorem that says, and copy this down, that if c squared is greater, if the hypotenuse square is greater than the sum of the legs square, then you have an obtuse triangle. If the hypotenuse square is less than the sum of the legs squares, then you have an acute triangle. Since here is C and 121 happens to be greater than 100, then what is this? Well, this is, of course, an obtuse triangle. Okay, that's an obtuse triangle. So pretty neat. Okay, so here is one for you. Tell whether the triangle is acute, obtuse, or right. So go ahead and pause the video. Try these two. Tell whether it is acute, obtuse, or right, and then play the video and see if you got it right. Okay, that's the best way to do it. So the way I want to do is, since I know that c squared is equal to a squared plus b squared, that's basically the Pythagorean theorem. I'll put it this way because if the hypotenuse is greater, then it's obtuse. If the hypotenuse is less, then it's acute. I want to know what this is, so that's 15 squared. Here would be my hypotenuse, right? Is equal to 5 squared plus 12 squared. Well, 15 squared is 225. 5 squared is 25. 12 squared is 144. Sorry, I put equal is plus, right? Plus 144. So that means 225 is greater than 169. So since 225 is greater than 169, this is an obtuse triangle. Make sure you pause the video and so you try that one if you haven't tried so already, and then play it and see if you have it right. Again, I'm gonna say, well, 15, because that's my hypotenuse, if it is a right triangle. So 15 squared is equal to 12 squared plus 10 squared. That's 225 is equal to 144 plus 100. That means 225 and 144 plus 100 is 244. That means the hypotenuse, the square of the hypotenuse is less than the square of the legs. Therefore, this is an acute triangle. Okay, see how easy that is? So this lesson is pretty simple, so make sure you practice it. So here is a word problem. Mr. Kelly is 125 feet directly north of Mr. Brust. So remember, you have north, south, east, and west. Right, north, south, east, and west. So Mr. Kelly is 125 feet directly north. So here's Mr. Kelly. From here is north, that means he's up, right? And that's 125 feet. And then from Mr. Brust, this is Mr. Brust. They both think they are Jedis. Crazy. Directly to the east would be to the right of Mr. Kelly. 500 feet away, right there. That's Darth Vader. The question, which Jedi is closer to catching Darth Vader? And if so, how much closer? Well, we know Mr. Kelly is 500 feet from the Darth Vader. This is Darth Vader right here. And then with Mr. Brust will be how far? Notice that would be the hypotenuse. Since this is north and this is east, that's basically a right angle right here. So now I know this is the hypotenuse. So I'm looking for x, right? So we have that C, remember the shortcut, is equal 125 square plus 500 square. So now that means that C is equal, and I go here, the square root of 125 square, put something else, 125 square plus 500 square. Enter. So notice that's 515.4 approximately. Okay, so that's 515.4 approximately. So that's approximately 515.4 feet. So who is closer to catching Darth Vader? Well, that would be Mr. Kelly. Is closer, right? By, well, the difference between 500 and 515.4 is 15.4 feet. And that would be the answer. Mr. Kelly is closer by 15.4 feet. Okay, so let's try the last two. Right here, find x, leave answer in simplest radical form. Again, x is my hypotenuse, because that's my right angle, so make sure you draw them like that. Okay, so I have that c, or x, is equal to the square root of 10 square plus 5 square. All right, that means that that's 100 plus 25. That means that's the square root of 125. So to leave these in simplest radical form, another way to know that is that I know that 25 is a perfect square, and 25 goes into 125 5 times. So I'm just going to do it this way. See, 25 times 5. Now, what is the square root of 25? Because 25 is a perfect square. Well, the square root of 25 is 5. So that comes out. And then this 5 right here, that's an irrational number that stays in. So here is my answer. Last one, classify the triangle as right, acute, or obtuse. Since I'm classifying, I'm going to find C, and I'm going to put it first. I'm going to say 13 square is equal to 6 square plus 8 square. 13 square is 169. This is 36. This is 64. This is 100. This is 169. So that's not equal. So 169 is greater than 100. Therefore, this is an obtuse triangle. All right. So for a summary, make sure you summarize. I gave you 2 shortcuts. I told you that to find C, if you're looking for the hypotenuse, then you want to say, well, C is equal to the square root of a squared plus b squared. If I want to find a leg, then I want to say, well, a is equal to the square root of c squared minus b squared. Remember that if it's acute, then c is less than a squared, or c squared, I'm sorry, is less than a squared plus b squared. If it's a right, this is acute, right, that means that c squared equals a squared plus b squared. And obtuse, that would be that c squared is greater than a squared plus b squared. And pretty much this summarizes what you've learned today. So happy practice. See you in class.